For as long as we've had history, we've stared up at the stars and wondered, are we alone? Well, we might be closer than ever to an answer. Just around 40 light years away, which is basically our cosmic backyard, a tiny, dim star is home to not one, not two, but 7 planets the size of our own. 3 of them are in the Goldilocks zone, that perfect spot where liquid water, the stuff of life, could actually exist. We might have found the most promising candidates for a new Earth yet. But here's the wildest part. We're already drawing up the plans to go there. Back in 2017, something happened that completely rocked the world of astronomy. Scientists using a telescope in Chile called TRAPPIST confirmed a discovery that sounded like it was pulled straight from a sci-fi novel. They'd found an entire planetary system that was unlike anything we had ever seen before. The star at the center, TRAPPIST-1, is what's known as an ultra-cool red dwarf. It's barely bigger than Jupiter and way dimmer and colder than our Sun, and that faintness is exactly what makes it so exciting. Because the star is so cool, its habitable zone, the area where it's not too hot and not too cold for liquid water, is pulled in incredibly close. All 7 of TRAPPIST-1's planets are orbiting their star at a fraction of the distance Mercury orbits our Sun. A year on one of these worlds isn't 365 days. It's more like a day and a half to maybe 3 weeks. Just imagine having a birthday every few weeks. This bizarrely compact setup would create a view that's hard to even imagine. If you were standing on one of these planets, the others would hang in the sky like gigantic, breathtaking moons, some appearing even larger than our own moon does from Earth. This system isn't just some cool oddity. It's our single best shot right now at finding life beyond our solar system. With 7 rocky, Earth-sized worlds, the potential is just staggering, and 3 of them might have just hit the cosmic jackpot. Let's meet TRAPPIST-1, E, F, and G. These are our 3 best shots for finding a habitable world, and each one is a totally unique frontier. We know they are all similar in size and mass to Earth, and we're pretty sure they're all rocky. TRAPPIST-1e is the closest of the 3. It's right on the warm, inner edge of that Goldilocks zone. While it gets less energy from its star than Earth does from the Sun, models suggest a tantalizing possibility. TRAPPIST-1e could have held onto its atmosphere for billions of years. An atmosphere, maybe thick with carbon dioxide and water, could create a warm, wet world, a perfect incubator for life. The James Webb Space Telescope is squinting at this system right now. And while the star's own light can interfere with the data, figuring out these atmospheres is one of its most important jobs. Then there's TRAPPIST-1f. This one is a bit further out, and it could be a cooler, water-covered planet. Picture a global ocean under a dim red sun. Because these planets are huddled so close to their star, they're probably tidally locked, with one side in permanent daylight and the other in endless night. If life exists here, it might be in the Terminator zone, the twilight ring between the light and dark sides, where temperatures could be just right for liquid water. Some recent hypotheses suggest that volcanic activity could have supplied these worlds with plenty of water, meaning some could be vast oceans, while others might be more dry and volcanic. And finally, there's TRAPPIST-1g, the biggest of the 7 and the farthest out in the habitable zone. It gets about as much light as Mars, but if it has a thick atmosphere, it could trap enough heat to stay nice and temperate. This sheer variety is what has scientists so fired up. We don't just have one shot at finding a livable world, we have 3 very different possibilities in the exact same system. So, would you pick the warm, humid world E, the global ocean of F, or the bigger, cooler G? Let me know in the comments. The only way to know for sure is to actually go there. And that leads us to one of the biggest challenges humanity has ever faced. The TRAPPIST-1 system is about 40 light-years away. That number sounds simple, but the distance is almost impossible to wrap your head around. It's roughly 229 trillion miles. If you hopped aboard New Horizons, the fastest spacecraft we've ever built, it wouldn't be a trip of years or even centuries. It would take about 817,000 years to get there. To put that in perspective, our entire recorded history as a species is only about 5,000 years long. Civilizations would rise and fall hundreds of times before that probe even arrived. The problem is fundamental. Our conventional rockets just don't have the juice. They have to carry their own fuel, which is incredibly heavy, and the physics just doesn't work for traveling between stars. For all of human history, the stars have been a beautiful but unreachable backdrop. But what if we could finally change that? What if we could build a ship that didn't have to carry its fuel? What if we could ride a beam of light? This is where things get truly wild. Meet Breakthrough Starshot. It's a $100 million research program with one of the boldest goals imaginable: to build the first real interstellar spacecraft. It was founded by physicist Yuri Milner and backed by people like the late Stephen Hawking. So this isn't just a fantasy, it's a serious engineering problem they're trying to solve. The idea is both brilliant and mind-bogglingly difficult. Instead of a huge rocket, you start with a tiny gram-scale robotic probe called a Starship. It's a fully functional spacecraft, cameras, sensors, navigators, and power, all shrunk down to a wafer the size of a postage stamp. This little chip is attached to a light sail, a super-thin sail just a few meters wide but only a few hundred atoms thick. The engine, however, stays on Earth. Starshot's plan is to build a massive, kilometer-wide array of lasers on the ground. Together, these lasers would fire a single, hyper-focused 100-gigawatt beam of light. That's more power than a nuclear power plant. The beam would hit the light sail, and the pure pressure from the photons, the particles of light, would accelerate the tiny craft with an unbelievable force. In just a few minutes, the nanocraft would be traveling at 20% of the speed of light. That's over 100 million miles per hour. At that speed, a trip to our nearest star system, Alpha Centauri, would take just over 20 years. The journey to TRAPPIST-1 would be longer, maybe around 200 years, but we're now talking about a timescale that fits within human history, not geological time. A message sent back would still take 40 years to reach us, but for the first time ever, we could see a planet outside our solar system up close within a few generations. Of course, the challenges are enormous. We'd have to build the most powerful laser in history, create a sail that won't instantly melt, and figure out how to communicate across trillions of miles. But the work is already happening. In 2025, researchers even developed a new AI-optimized light sail design that's incredibly thin and reflective, which is a huge step forward. The Starshot initiative is laying the groundwork for this mission right now. This isn't some far-off dream, the work has begun. Exploring deep space has never just been about finding another rock to stand on. It's about figuring out our place in the universe. The TRAPPIST-1 system gives us the best reason we've ever had to make that leap. It's a perfect laboratory for understanding how planets are made and for figuring out if life is a bizarre fluke or a cosmic rule. The journey that Breakthrough Starshot is proposing is our generation's moonshot. It's a mission that would have to unite nations and span generations, all driven by that core human impulse to explore, to discover, and to know. The very first image sent back from one of those worlds, whether it's a coastline, a strange cloud, or just the glint of light off a distant sea, would change everything. It would be the moment we finally prove that the universe isn't just something to look at, but somewhere we can go. We've found 3 of the most promising new worlds yet, and for the first time, the trip is no longer a fantasy. It's a plan. Thanks for watching. If you want to stay updated on what might just be humanity's greatest adventure, make sure to subscribe. What do you think is waiting for us on the TRAPPIST-1 planets? Let us know in the comments below.